Hey guys, we're going to talk a little bit about probability. I'm not going to get too hung up in a lot of details, but just going to lay out some kind of key pieces that I think will be helpful for you. So the first is basically what is probability? So we're going to define it, write down some key ideas, and then kind of move on from there. So probability. And probability is how likely, or the likelihood, of an event happening. We love to use like the event is flipping tails when you flip a coin, right? Or drawing an ace out of a deck of cards. There's lots of those events that we use, but the probability is how likely is it that that event is going to take place the way we expect it to. So we use the letter P for probability, that makes sense. And we use E for event. And when we want to calculate probability, we're going to do it as a fraction. And so we divide the how many possible desired outcomes there are, out of the total outcomes. So if we're flipping a coin, to flip a coin, the probability is 1 out of 2. Right? Tails is one outcome out of 2 sides of the coin. Or if we're rolling a die, rolling a 3 would be 1 out of 6. Okay? So that's kind of our formula for whenever we're doing stuff with probability. And that's a pretty general formula. But definitely comes in handy. Now, a couple kind of not wrinkles, but a couple key pieces of this formula. If the probability of an event equals 1, that means it will happen. If the probability of an event is 0, it means it definitely will not happen. Okay? So just kind of, and then anything in between there, right? 50-50 or things like that. So we can talk about a couple different things with probability, whether we're using different events or whatever, but we can talk about independent events and we can talk about dependent events. So let's kind of take a second and just run through that real quick. So independent, 2 events are independent if the probability doesn't change after the first one occurs. And then dependent means that the probability changes if the first thing happens. So here's kind of my favorite example of that, and it uses the phrases with replacement or without replacement. So I'm going to look at an example. And I'm going to say there's 3 black marbles. There's 6 green. And there's 4 yellow. And I want to decide what is the probability that I pull out a green marble, then a black. And I'm going to show you 2 different wrinkles on this situation. The first is, I'm going to talk about what happens if I do it with replacement. And then what happens if I do it without replacement. Okay? So the first thing we want to do is we want to pull a green marble. How many, now probability is desired out of total. So there's 6 green, that's what I desire. But then there's also the total, right? So it's 6 green out of a total of 13 marbles. So 6 green out of a total of 13 marbles. So that's my chances of pulling a green one on the first pull. Then, because it says with replacement, that means when I go to make my next pull and try and pull a black one out, that means that I'm back to a full bag. And so the probability doesn't change at all, it just stays, the outcomes stay the same. Granted, the top's going to change because I'm now desiring black, but now I have 3 black out of 13 total. So with replacement, the odds are of going like this is 18 over 169, or almost 10%. Okay? If I do without replacement. So now my green is still 6 out of 13, but we're going to assume that I took a green one out. So I've got my marble, I pull it out, it's green, I set it aside. That means that in this next round, because I set it aside, I don't put it back in, there's only 12 marbles in the bag. And that changes things a little bit. So now when I pull black, it's 3 out of 12. So I still have 18 ways, or 18 desired outcomes of going green and black, but now I only have the total outcomes has changed because the denominators have changed. So 13 times 12 is only 156. Could I reduce that fraction? Of course I could reduce that fraction. Am I going to reduce that fraction? Nope, not today. Okay? So that's independent versus dependent, and knowing if the probability changes when I go to the next round. The other thing I want to just talk to you really quickly about is mutually exclusive. I'm going to go through 2 examples for this. In the first example, I'm going to use, let's do, let's make it fun. So I'm going to do letters of the alphabet. Oops. Letters of the alphabet. And then we'll do rolling a die because that's a nice easy one. So what is the probability I'm going to back that up. Let's get rid of the rolling a die. I don't want too many events going on. I'm just going to use letters of the alphabet. Okay? And I want to know the probability of pulling a letter from Visto or a letter from, let's just use Dauk. Now there's no overlap between these 2 choices. So the probability of getting a letter from Visto is 5 out of 26. And the probability of getting a letter from Dauk is 4 out of 26. So the probability of getting, if I just randomly had a bag of letters and I pull a letter out, the probability that it would be from either Visto or from Dauk is 9 out of 26. Those are mutually exclusive because there's no overlap. Okay? And now I want to show you one where there's some overlap. So I'm going to talk about, now I'm going to do my rolling a die example. Okay? And I want to know the probability of rolling an odd number or the probability of rolling a prime number. So this gets a little bit tricky because when I think about my subsets, Odd numbers, I'm thinking about 1, 3, and 5. Prime numbers, I'm thinking about 2, 3, and 5. So I see some overlap, right? The probability of rolling an odd number is 3 out of 6. The probability of rolling a prime number is 3 out of 6. But I need to account for the fact that 3 and 5 were double counted. They showed up in both fractions. And so I need to subtract it out to show that, sorry, I got a little off, to show that we don't want that. So when I do that, instead of having a probability of 6 out of 6, it drops me down to 4 out of 6. So those are mutually exclusive events, or events that have a little bit of overlap, right? That would be inclusive, but I just like to think of them all as mutually exclusive. So be really careful when you're looking at what are your outcomes, and if you are trying to combine two events, making sure that the outcomes of one don't overlap. If they do, you're going to have to do some subtraction to account for that. So there's some basic probability. Obviously, remember, it all comes back to this lovely fraction at the top. This is going to be super helpful for you. So make sure you kind of understand how to use that fraction.